In example 3, we have a variety of problems to work with. I believe there's 6 in total. For part A, we're going to work on finding AD. Well, AD here and DC are going to have the same length, so AD is 16. We can use that knowledge here to solve for EF. EF is x plus 1, and FG is 2x minus 1, and those are going to have the same length. So we could subtract 1, add 1, and divide by 2. And x will be 1 here. Let's see if that worked out. So EF is the one we're actually trying to find. 1 plus 1 is 2. So we're going to state here that EF is 2. That's the solution. But we can also double check with FG. So 2 times 1 is 2, minus 1 would be 1. So we might have made a mistake somewhere. I just caught it right now. So 2x minus x is not 2x, it's just x. So x is going to be just 2 for this one. If we substitute 2 in then, 2 plus 1 is 3, so EF is 3. And then 2 times 2 is 4 minus 1 is 3. That was an easy mistake to make. It happens from time to time, not very often, but sometimes. And the only way you're going to catch your mistake is if you check your work. So try to do that on each one of these. Here's PQ. Notice that PQ and QR are congruent, so their measures are equal. We can subtract 3x here. 2x is equal to 8. Then divide by 2, and x will be 4. We want to find PQ though, not just what x is. So 5 times 4 is 20. PQ is going to be 20. We can verify this situation by substituting in for QR here, or excuse me, by finding the measure of QR by substituting in x. So 3 times 4 is 12, plus 8 is 20. In this example, we'd like to find LK. Notice that LK is congruent to KN, so we can set x equal to 2x minus 3. We'll subtract x from each side. This is not the only way to do this. Matter of fact, your algebra teachers might have taught you to subtract 2x from each side, and that's fine. But this way works as well. You got to remember that x minus x is 0 though, and write that down, so it's kind of tough sometimes. We want to find LK. Well, LK is just x, so LK is going to be 3. And then if we substitute in here, 2 times 3 is 6, minus 3 is also 3. So KN and LK work out to be the same. That's good for us. PQ here is going to be congruent to RQ, so we can set x plus 2 equal to 2x minus 1. We'll subtract x from each side and add 1. So we think x will be 3. To find PQ, we'll just take 3 plus 2. So PQ is 5. 2 times 3 is 6, minus 1 is also 5. And RQ would be the same length as PQ. In this example, part F, we're going to find AD and BC. To find AD, we can look at our congruent tick marks. We notice that AD is congruent to DC, therefore they have the same measure. So AD will be 12. To find BC, we'll have to solve for x and substitute in. And we know that AB here, which is 3x plus 1, is equal to BC, which is 2x plus 6, or their measures are equal. So we'll subtract 2x from each side. X plus 1 is equal to 6. Subtract 1, and we get x to be 5. Remember, we want to substitute back in to find BC, so 2 times 5 is 10, plus 6 is 16. Good idea to verify that by utilizing that same process to find AB. So we'll substitute 5 in for x. 3 times 5 is 15, plus 1 is 16, and we have 2 congruent segments.